Well, today we will show a structural analysis of a column calculated in accordance with the harmonized standard EN 13445-3. This is our column. Let's look at the item properties. The name is T001. The standard is EN 13445-3 edition 2021. The units are megapascal and degrees centigrade. These are the default for standard flanges. This is the materials. This is the material set: carbon, manganese, silicium. Well, factor in creep range doesn't matter because we are not in the creep range. Geometry, it is a vertical item, it's not a jacketed vessel. Test pressure calculation, the test will be hydrostatic. The test pressure calculation is automatic. Note this warning: item is tested in horizontal position. That means that the test pressure must be increased on the difference between the static head when the vessel is vertical and the static head when the vessel is horizontal. Location, where is this located? Well, this is located in Italy. Location is Priolo Gargallo in Sicily, and if we want to see where the location is, okay, in Sicily is near Catania, near Syracuse. Catania is a little bit at the north of Syracuse. These are the coordinates, and the coordinates are shown by which we can show the location in the map. Wind. The wind is calculated according to the national annex of the European standard EN 1991. Here you have all the characteristics. So the wind zone is the wind zone 4, the terrain roughness, the basic wind speed, which is 28 meters per second, the altitude is 28 meters, and all other characteristics that are required to make a calculation for wind. The same is for seismic calculation. The usage factor is 1.5. The usage class is the third one. That means that the the nominal life is 75 years. The limit state is SLC according to the Italian standard. That means stato limite di prevenzione del collasso. That is total failure of the column. These are the characteristics of the seismic acceleration, the subsoil characteristics, etc., etc., etc. Well, the fatigue is not required. We have now to give a look to the operating conditions. The internal pressure design temperature is 150 degrees. The internal pressure is 0.5 megapascal, that means 5 bar. The external pressure design temperature is 20 degrees. The external pressure is practically vacuum, that means 0.103 megapascal. The corrosion allowance is 1 millimeter. There is no external corrosion allowance. There is no weld overlay or cladding or things like that. And now we have to update to this, and start looking at each single component of this column. The philosophy of the calculation is, first of all, we must check component by component the resistance to internal and external pressure. At the end, we will make the structural analysis considering also wind and earthquake. Note that for wind, having given these data, we have the wind curve, the wind pressure curve. So you see that's smaller with when the height is low, and then it's increasing up to the top of the column, and you have here all the values of the wind pressure in a Newton per square meter. Then we close this, and if we want to see the accelerations, we have these curves that give us the acceleration in horizontal and vertical directions as a function of the period of the column. Now we close this and we start examining our column component by component. First of all, we take the upper head here, we open it, thickness 10 millimeter, inside diameter 1 meter, head ratio is 2, nothing particular. We look at the preliminary report. The minimum required thickness is 2.85 millimeters. Certainly the joint efficiency is 1 because there is no transverse weld. There is just a warning. You look at the yellow warning. Heat treatment may be required on this component when manufactured from one piece. Of course, it is manufactured from one piece. Therefore, the elongation to 22.68% is greater than 5%. Therefore, a heat treatment is required in this case. Well, okay, we close this component. We open this cylindrical shell. This cylindrical shell, of course, has the same diameter, has a thickness of 11 millimeter. Here you have also the 0.3 millimeters of fabrication tolerance. The preliminary report says that for the internal pressure, the minimum thickness is 2.78 millimeter. For the external pressure, it is 9.85, so the thickness used is sufficient. No warning, we close it. Then we have a conical piece. This conical piece has a thickness of 12 millimeter, and the minimum inside diameter is 1 meter. The maximum outside diameter is 1.5 meters. The angle is 30 degrees. Preliminary report says that for the minimum thickness of required thickness at the joint junction is very small, but of course there is also the problem of the external pressure. The external pressure, in any case, the minimum thickness is 4.31 millimeters. Also in this case, maybe there is a warning. No particular warning. We close it and we open the lower cylindrical part. This lower cylindrical part has a diameter of 1.5 meter. Of course, all these components are made of carbon steel material P355GH. The preliminary report here says that for the internal pressure, the minimum required thickness is 3.69. For the external pressure is 11.69. Therefore, the thickness which has been used, the 13 millimeter, is sufficient. We close it. We now go to the base of the column. There is a domed end at the base of the column. The base is composed, in fact, of two pieces, an ellipsoidal end. Diameter, of course, is 1.5 meters. The thickness of this end is 10 millimeter. And, well, let's look at the yellow wording here. Of course, like the upper end, here there is the problem of the heat treatment due to the fiber elongation, which is 22 point something %. And the skirt has a thickness of 15 millimeter, outside diameter 1 meter, 500 and something. We look at the base ring. The base ring has a width of 300 millimeter. The width to place in circumferential direction of top plate in circumferential direction is 410 millimeter. You see, this is composed of a series of reinforcements. Let's check the wording. Okay, the wording yellow, the yellow wording was referred to the end, and the preliminary report doesn't give us any particular information. So we close the base ring, and now that we have examined all the components considering only pressure and temperature, of course internal and external pressure, and we go to the item report. When we go to the item report, the stress analysis for wind and earthquake is automatically made. And you see, structural analysis, there is a warning here, a red warning, which was not present when we considered only pressure and temperature. But if we now consider also the wind and the earthquake, we get a warning. We look at the report. And we have, before looking at the report, we have this information. The calculation report contains one or more validation errors marked in red. Errors can be found at the following page or pages 48. Okay, we accept this. We have just to see the report. Better to make it bigger. And we get a report, the complete report of the column, starting, of course, on the design conditions, table of contents, summary of item properties. Well, we go directly to page 48. Page 48. Let's go a little bit further. We are now at page 32. Page 46, we are almost arrived. Here, okay, here there is the warning. Maximum stress ratio at external pressure is not satisfied. Thickness should be increased. Code reference, and here there is the paragraph of the codes that has to be considered. If you remember, the explanation I have given on this problem of the external pressure, when the compressive stress due to the external pressure, which is not only in the circumferential direction, it's also on the axial direction, because the external pressure acts also from the top to the bottom, we have to consider the superposition of this buckling to the buckling due to wind and earthquake, because wind and earthquake, they cause a bending stress with compression from one side and tension on the other side. If you consider the compressive stress sigma c, and you detract from this compressive stress the stress which has been already caused by the pressure, the ratio of these two effects, external pressure divided by maximum allowable external pressure plus compressive stress on the allowable compressive stress, having taken out the part of the stress which has already been considered in this ratio, well, if the sum of these two factors is greater than 1, the buckling condition exists. You have to decrease one of these terms by increasing the thickness. First of all, of course, we must understand which is the interested section. We go up a little bit, and section is section 4. That means the connection between the conical shell and the lower cylindrical shell. We have also to check what is the loading case where we have got this problem. The loading combination is LC7, which is external pressure plus weight plus earthquake plus local loads that in our case do not exist. We close the report and we go here to increase this thickness, the thickness of the lower cylindrical shell. Instead of using 13, we use 14. Of course, this for pressure is always verified, and we have now to check again the item report. The item report doesn't give us now any particular warning. We print the report. We make it bigger, no, too much, and we go again to page 48. LC7, 46, and now we are at page 48. You see this ratio, which before was 1 point something, now is a little bit lower than 1, is 0.87. So now we are sure that our column has been verified also for the structural analysis. We close the report. Just a small note to better understand the cases for which the load combination. You have here the list of all the loads combination that
had been considered in the analysis.
The combination which gave the problem was LC7, which was the combination of external pressure plus weight plus earthquake. Okay, now I think that our column has been thoroughly verified, and we can close this example, and I thank you very much for your attention.